Welcome to the December AJP-Heart and Circulatory Physiology video table of contents, or from the editor's desk. This month we've published one review article, 33 original review articles, and 2 letters to the editor and their responses. We have some superb studies this month, and I know you're anxious to get a synopsis, so let's get started. Hagashi et al. Investigated whether miR-145 exhibits a cardioprotective effect in a rabbit model of myocardial infarction and in H9C2 rat cardiomyoblasts. Control miR-RNA, or miR-145, encapsulated in liposomes, were intravenously administered immediately after start of reperfusion following ischemia. Rat cardiomyoblast cell line was also transfected with miR-145. Infarct size was smaller and cardiac function better in the miR-145 transfected hearts. miR-145 inhibited the growth of H9C2 cells and accelerated the transition of LC3B1 to LC3B2 and increased phosphorylated PAKT in the H9C2 cells at 2 days after miR-145 transfection. The authors conclude that post-MI treatment with miR-145 protected the heart through the induction of cardiomyocyte autophagy by targeting FRS2. Study by Toth et al., a link was established between endothelial function and functional hyperemia and neurovascular coupling responses in mutant mice either overexpressing or deficient in ENOS, and the role of the P2Y1 receptor in purinergic glioendothelial coupling, an important issue in the aging process. They found that in ENOS knockout mice, and after pharmacological inhibition of NO synthesis, there was a decrease in the cerebral blood flow responses to somatosensory cortically evoked responses by whisker stimulation and by administration of ATP. Overexpression of ENOS enhanced NO mediation of functional hyperemia. In control mice, the selective and potent P2Y1 receptor antagonist MRS-2179 attenuated both whisker stimulation-induced and ATP-mediated cerebral blood flow responses, whereas in ENOS knockout mice, the inhibitory effects of MRS-2179 were blunted. The authors conclude that purinergic glioendothelial coupling during neuronal activity shows a role for ATP-mediated activation of ENOS via P2Y receptors in functional hyperemia. Wang et al. Hypothesized that soluble epoxide hydrolase in vascular smooth muscle cells plays an important role in atherosclerosis and injury-induced neointima formation. In this study, soluble epoxide hydrolase expression in human autopsy atherosclerotic plaque was determined by immunohistochemistry. Also, carotid artery balloon injury was performed after adenoviral-mediated overexpression of soluble epoxide hydrolase or oral administration of a potent soluble epoxide hydrolase inhibitor in Sprague-Dawley rats. Soluble epoxide hydrolase was highly expressed in vascular smooth muscle cells of the intima and media within human atherosclerotic plaque. In vitro, PDGF-BB upregulated the expression of vascular smooth muscle cells post-transcriptionally and promoted cell proliferation and migration. The latter effect could be largely attenuated by the soluble epoxide hydrolase inhibitor. These data established the impact of soluble epoxide hydrolase expression on atherosclerotic progression and vascular remodeling after injury, thus identifying a novel integrative role of soluble epoxide hydrolase in vascular smooth muscle cell phenotypic modulation and migration. Parenchymal cerebral vessels may regulate flow differently than the more traditionally studied Peel vessels. Pyres et al. Studied the role of calcium entry by TRPV3 channels on parenchymal vessel reactivity. They found that carvacrol, a monoterpenoid compound, increased the frequency of unitary calcium influx events through TRPV3 channels in cerebral arterial endothelial cells. Carvacrol-induced TRPV3 sparklets were inhibited by the selective TRPV3 blocker isopentenyl pyrophosphate. TRPV3 sparklets have a greater unitary amplitude than previously characterized in TRPV4 or TRPA1 sparklets, suggesting that TRPV3-mediated calcium influx could have a robust influence on cerebrovascular tone. In pressure myography experiments, carvacrol caused dilation of cerebral parenchymal arterioles that were blocked by isopentenyl pyrophosphate. Taken together, these data suggest that TRPV3 sparklets cause dilation of cerebral parenchymal arterioles by activating IK and SK channels in the endothelium. Finally, Milani Nejad et al. Investigated the cross-bridge cycling rate and its regulation by muscle length under near physiological conditions in intact right ventricular muscles of non-failing and failing human hearts. The failing myocardium showed a negative force-frequency relationship and beta-adrenergic desensitization, indicating the expected pathological myocardium in the right ventricles. A length-dependent regulation of cross-bridge cycling kinetics was found in human myocardium. Decreasing muscle length accelerated the rate of cross-bridge reattachment in both non-failing and failing myocardium equally. There was no major differences between non-failing and failing myocardium at each respective length, indicating this regulatory mechanism is preserved in heart failure. This study showed that muscle length regulates cross-bridge kinetics in human myocardium under near physiological conditions, and that these kinetics are preserved in right ventricular tissues of heart failure patients. Thank you for watching this edition of AJP Video Table of Contents for December. A reminder that the APS has eliminated submission fees for manuscripts starting in January, so this should be a great time to send us your best work. I'll see you in the new year, and from all of us at AJP Heart and Circulatory Physiology, have a healthy, safe, and prosperous 2016.